Hello people, welcome to the module 7 of this basics of engineering mechanics. Before this module, I hope that every one of you has seen the past 6 modules, because those 6 modules are the basics. If you're going to learn this module, you have to know the basics of cross product, dot product, etc. what I have taught in past modules. Okay, so in this module I'll be using a Verignon's theorem to find the sum of moments, and we'll solve a two-dimensional moment problem. Okay, so if you recall the definition of a moment of vector p, I might be changing some notations, but the real thing will remain same. We have to multiply the position vector and we have to cross it with the force vector in terms to get the moment. Okay, so Verignon's theorem says that the moment of any force is equal to the algebraic sum of the moments of the components of that force. Okay, so there is a force which is represented as F is equal to F1 plus F2, then the moment which is R times F can be written as R times R cross F1 plus R cross F2. Okay, so this is the basic rule. So in this example, we have taken an example in which there is a force which is applied at particular angle, which is on a slope of 3 over 4 here, and this force, and in this I section we will try to find out the ability of this force F to rotate this bar by center O. Okay, so if we pull from the in the direction as a line of action of this force, what is the ability of this bar to rotate about point O? That we'll try to find out. So there are two methods to do that. The first one is the vector method and the second is the scalar method. So this is the vector method I'm going to tell you first of all. Okay, so if you have seen my previous videos, I have made a video on how to represent force in 2D. Okay, so if you haven't seen that video, please do check that video. And so if we want to represent this force A and B in that 2D format, that we can use as that vector F, that AB can be written as, we have to move 4 units in x direction and 3 units in negative y direction. Okay, that can be written as 4i minus 3j. Okay, here this won't be the mode, this will be the vector. Now if we want to find the modulus of this vector, that we can do by square root of the individual component, that is 4 square plus 3 square, and the value you will get is 5. So if you want to find out the unit vector in the direction of the force vector, that you can write as AB upon mod of AB, vector AB upon mod of vector AB, that you will be getting as 4i over 5, that is 0.8 times of I, minus 3j over 5, that is 0.6 times of j. That is the unit vector in the direction of AB. Now this force can be written as, this force vector can be written as the moment, the value of magnitude of force multiplied by the unit vector, that is the magnitude is 20 newtons. So 20 times 0.8 is 14, 16i, and 20 times 6 is 12j. Okay, so this is the force vector force in the representation of I comma j. So that is 16i minus 12j, that I'll write it here. The force is 16i minus 12j. Now this, we have to find the moment about O, the tendency of rotation of this bar with respect to O. So we can take the vector OA. Okay, so vector, position vector OA can be written as, we have to move 3 units in positive y and 2 units in positive x direction. That means 2i plus 3j. Okay, so now the moment of this force, moment of this, because of this force, can be written as vector ROA crossed with force vector. Okay, so that means 2i plus 3j crossed with 16i minus 12j. Okay, that will be getting as minus 72k. I am hoping that you all know how to do the cross multiplication of two vectors. If you haven't seen the past videos, please go and check the videos in the playlist. Okay, so minus 72k means minus 72 in the negative z direction, or 72 Newton meters in anti-clockwise direction. That means the axis is perpendicular to this plane where this diagram is made. It is perpendicular directly downwards. Okay, so this is the vector method to find out the moment. Now we have one separate scalar method to find out that thing, the moment also. So if you want, you can take this OA and you multiply by this force value, you will get the moment. But since this OA is geometrically difficult to find out, then we'll take the components of this force. Okay, and I think I already told you how to find the components of the force. So components, horizontal component and vertical component of the forces. So F horizontal and F vertical. F horizontal will be, it is on 4 over 5, 20, that's 16. F vertical will be 3 over 5 times 20, that is 12 newtons. So now we have to take the moment of, because of this force F horizontal and because of this force vertical. Now we have to take a assumption of a direction. Okay, so suppose the clockwise moment is positive, we will take that in mind. So this FH and FL both are producing a clockwise moment with respect to O. So both the moment value will be positive. So moment can be written as FH times DH perpendicular. The distance is this one, DH perpendicular, plus FV times DV perpendicular, and the distance is this one, DV perpendicular. That can be written as FH is 16 times DH perpendicular is 3 plus FV is 12 and DV perpendicular is 2. That will be 72 Newton meter in clockwise direction. So if you see, both the results using the scalar method and vector method are same. Okay, so I hope you all get the clarity about this thing. Thank you so much.